It is based on the principle that current doesn't flow between equipotential point. Here we connect 4 resistors and form a bridge, and between any 2 points, if there is no current flowing, if we connect the opposite ends of the wires, if no current is flowing through the wire, it means that they are at equal potential. Current flows only when one end is at higher potential, another end is at lower potential. So Wheatstone's network consists of 4 resistors, R1, R2, R3, and R4, which are connected to form a quadrilateral. So this is the structure of a Wheatstone bridge. You can see. So here a source of EMF is connected between 2 diagonally opposite points as shown. A sensitive galvanometer is connected between other 2 diagonally opposite points B and D. So we have connected one pair, diagonally opposite pair, with the battery and a key, and other pair, diagonally opposite pair, they are connected through a galvanometer. So due to source E, current starts flowing through all the resistances and all branches. So I is the current which starts flowing, and this I current splits up into 2 parts, I1 and I2. So now you can see I1 current is flowing through R1 and I2 current is flowing through R3. And at junction B, some part of current I1 flows through the galvanometer and some part goes through the R2. So let's say that IG current is flowing through the galvanometer, and the remaining current, because IG current is flowing through the galvanometer, this is current I, which was flowing through R1. Now at this point, at this junction, this current is, it splits up into 2 because we have 2 branches here. So if IG current is flowing through the galvanometer, then the remaining current is I1 minus IG. Then I1 minus IG will flow through the resistor R2. And you can see here, 2 resistor R3, we have I2 current flowing, and this IG current and this I2 current, these both currents, they meet at the junction D. So at junction D, current I2 and IG meet and flow together through R4. So through R4, we have I2 plus IG current flowing. Okay, now you can see through resistor R2, we have I1 minus IG, and through resistor R4, we have I2 plus IG. So at junction C, both the currents will meet. IG cancel ho jayega hamara, and we are left with I1 plus I2 only. And I1 plus I2 is nothing but I. Because together, if we take I1 plus I2 together, it makes I. Okay, so this is the structure of a Wheatstone bridge. Please draw this structure in your notebook first. We connect resistors in the form of a quadrilateral. So we have connected resistors like this. So you can see the opposite ends. Okay, opposite ends of this A and C. A and C are the opposite ends. Similarly, we have B and D. These are the opposite ends. Okay, so these are diagonally opposite ends of the Wheatstone bridge. So A and C are connected through a battery and a key. One pair of diagonally opposite end is connected through a battery and a key. Okay, and other diagonally opposite ends are B and D. Okay, so B and D are connected through a galvanometer. So this is the structure of a Wheatstone bridge. Now, if we assume that current I is flowing through this, this E, this generates current I. So this current I, when goes to point A is a junction. So current will split up into 2, I1 and I2. Now I1 current is flowing through R1 and I2 current will flow through R3. So I1 current when goes to this point B, again, it is a junction. So again, it splits up into 2. So we have I1 minus IG and IG. IG, we are taking the current through the galvanometer, we are considering as IG. So IG current is flowing through the galvanometer, and the remaining current is I1 minus IG. It is going through resistor R2. And similarly, if we look at this R3, so I2 current is flowing through R3. And when it reaches junction D, it meets the current which is flowing through galvanometer. That's IG. It meets the current IG there at junction D. So I2 plus IG collectively, we have the combination now. Okay, इसको हम add कर देंगे. Sum जो होगा I2 plus IG, it will pass through R4. Okay, now we have I2 plus IG through R4 and I1 minus IG through R2. They both meet at point C. So at C, IG is, we have plus IG here and minus IG here. तो प्लस आई जी माइनस आई जी हमारा कैंसिल हो जाएगा एंड वी आर लेफ्ट विद I1 प्लस I2 ओनली एट C. So this I1 plus I2 is nothing but I. Okay, so I1 plus I2 क्या है? I ही है ना. तो ये I करंट हमारा वापस जैसे आया था वैसे ही वापस चला जाएगा और आपकी बैटरी में अंदर आ गया नेगेटिव टर्मिनल. So this is the structure of a Wheatstone bridge. You have to draw this structure in your notebook. Please draw this. See, if this point B and this point D, if they are at the same potential, then no current will flow through this branch. If they are at the same potential, then no current will flow. Current flows only when the end points, the 2 points are at different potentials. But if they are at the same potential, then no current flows in the circuit. So if we assume that potential at B is equal to potential at D, then no current will flow through the galvanometer. And because galvanometer detects the current, detects the presence of current. If there is a current flowing through the galvanometer, then it shows deflection in that direction. If current is flowing in downward direction, it will show deflection in downward direction. If current is flowing in upward direction, it shows deflection in the same direction in which the current is flowing. So if no current is flowing means galvanometer shows no deflection. So we can detect the presence of current, presence or absence of current through the galvanometer. Okay, that's why we have connected the galvanometer there. So we have to maintain, we have to adjust the resistors values in such a way that galvanometer shows no deflection. And if galvanometer is showing no deflection, it means that both the points BB and B and D, they are at the same potential. तो अगर गैल्वेनोमीटर डिफ्लेक्शन शो नहीं कर रहा, इसका मतलब ये है कि बी और डी दोनों सेम पोटेंशियल पे हैं. क्योंकि अगर वो डिफरेंट पोटेंशियल्स पे होंगे तो करंट विल फ्लो एंड विच कैन बी डिटेक्टेड बाय गैल्वेनोमीटर. उसका पर्पस का फंक्शन ही यही है, यहाँ पे लगाने का उसका रीजन ही यही है कि हमें पता लगे कि करंट फ्लो कर रहा है या नहीं कर रहा. एंड इफ नो करंट इज फ्लोइंग थ्रू द गैल्वेनोमीटर, इसका मतलब क्या हुआ कि हमारा जो ब्रिज है दैट ब्रिज इज बैलेंस्ड. अ ब्रिज इज बैलेंस्ड. ओके,
बैलेंस हो गया मतलब इक्वल पोटेंशियल पे आ गया.
Yes. So if VB is equal to VD, then IG is equal to 0. No current will flow through the galvanometer, and we have considered this current as IG. G is the G for galvanometer. Okay. So this happens to be true only if R1 by R2 is equal to R3 by R4. So this is what we are going to prove here. Okay. ये कब होगा, ये कब डिफ्लेक्शन शो नहीं करेगा, जब ये रेशो इक्वल होगा. तो लुक एट दिस, R1 कहाँ है और R2 कहाँ है. R1 इस इधर वाला और R2 इस साइड वाला है ना, नीचे R3 by R4. So when R1 by R2 is equal to R3 by R4, then galvanometer shows no deflection. ठीक है. Now we have to prove it now. See, and we say in that condition when galvanometer shows no deflection और वो जो ratios है वो equal आ रहे हैं resistances के, तब हम बोलते हैं कि हमारा जो Wheatstone network है, हमारा जो bridge है, a bridge is balanced. And this condition that we have discussed now, R1 by R2 is equal to R3 by R4. This is known as balanced condition of Wheatstone's network or Wheatstone's bridge. Okay, so balancing condition for Wheatstone's network can be obtained by using Ohm's law. And see, यहाँ पे if we assume that VA is the potential at A, VB is the potential at B, VC is the potential at C, and VD is the potential at D. So these are the potentials at A, B, and C, A, B, C, and D respectively. So VB and VD, we are assuming ना कि अगर हमारा VB और VD इक्वल है तो गैल्वेनोमीटर में डिफ्लेक्शन शो नहीं होगा. तो VB is equal to VD है. तो अगर VB is equal to VD है और फिर आप पुटिंग नेगेटिव साइन देयर, तो माइनस VB और माइनस VD भी आपस में इक्वल होंगे, है ना. अब माइनस VB माइनस VD कर तो दिया, बट उसका पर्पस क्या है. अब आप क्या करोगे ये देखो. We are going to add this minus VB and minus VD to VA. Now see, अब हमें क्या मिलता है. हमने क्या किया, इसके आगे दोनों के आगे VA लगा दिया. तो VA minus VB is the potential difference across this line. Look at the cursor. So VA minus VB is the potential difference across this. And potential difference, how do we find potential difference? We'll apply Ohm's law here. It is equal to I1 R1. Okay, नहीं आया.
हम एक बार दोबारा बता दो.
V is equal to IR होता है ना बेटा.
हाँ,
है ना. तो अगर आपका देखो पोटेंशियल डिफरेंस IR के इक्वल है, ये हमें पता है, राइट, है ना. एंड वी हैव रिटन पोटेंशियल डिफरेंस हियर अक्रॉस दिस branch. Look at this branch only. This AB branch only. And in this AB branch, we have this R1 resistor and current I1 is flowing through this branch. Yes?
Yes, ma'am.
है ना? So VA minus VB can be written as I1 R1.
जी.
Potential difference is I1 R1. Similarly, we can write for VAT. Look at
I2 R3.
I2 R3. So VA minus VD is equal to I2 R3. I think someone was talking. VA minus VD is I2 R3. Okay. So we can write for these potential differences. So we'll get this. So I1 R1. This is I1 R1. This is I1 R1 and this is I2 R3. So these are equal. Any doubt?
No, ma'am.
Please write this in
अब
this.
हम यही चीज फिर उसके साथ कर लेंगे, इसको सी और
हाँ.
बी के उसके रिस्पेक्ट में करके कर लेंगे, अब बीसी को सब्ट्रैक्ट करके कर लेंगे.
हाँ जी, पहले आप ये लिखो
और फिर जो कॉमन आएगा उसको इक्वल करके बना के कर देंगे.
इजी है ना? देखो आपको सब कुछ पता लग गया है ना? इससे इजी डेरिवेशन क्या होता है कि बच्चे आगे प्रिडिक्ट करने क्या होने वाला है. बहुत जोर से बंद करो. हैव यू रिटन?
हाँ मैम, एक बार मैम इसका मैम अगले वाले का हम खुद डराइव करके देख ले एक बार, फिर आप बता देना.
ओके. थोड़ा सा okay. See, similarly, this is one. Similarly, we can take, because VB is VC, so we are going to subtract VC from both. So VB और VD दोनों में से हमने VC को subtract कर दिया. तो VB minus VC is equal to VD minus VC. This is what we'll get. Okay. So VB minus VC, because current flows from higher potential to lower potential, right? Current flows from higher potential to lower potential. So VB minus VC is I1 R2 and this VD minus VC is I2 R4. So we can write I1 R2 for this VB minus VC and I2 R4 for VD minus VC. Consider this equation as 2.
तो फिर अब जो ये दो इक्वेशंस आई है ना, इन दो जो 1 और 2 आई है, इनको 1 को 2 से डिवाइड कर देंगे, जिससे
Yes.
हमें मिल जाएगा R1 is by R2 is equals to R3 by R4.
Yes. Now we will divide. You all have written? So now we will divide. Okay. So we have this equation is first equation and this equation is a second equation. Now we are going to divide this. So on comparing this,
I1 कट गया, I2 कट गया दोनों साइड से.
yes. So this is the condition of Wheatstone Bridge. Balanced condition of Wheatstone Bridge. Clear? You're writing?
Yes, ma'am, written.
You all have written?
Yes, ma'am.
Okay, now we have a question based on this. Wheatstone Bridge can be used to compare two unknown resistances, to measure small strains produced in hard metals as the working principle of meter bridge, all of the above.
ए मैम, आपने नोट्स में भी लिखा है.
See, it is used to measure, it is used to compare to unknown resistances, but we'll soon start meter bridge. There we use Wheatstone principle as principle. So it is the working principle of meter bridge also, and it is used to measure small strains produced in hard metals also. All of the above is the correct answer. Next question. Wheatstone bridge is most sensitive when the arm ratio is equal to 1, less than 1, more than 1, or 0.
ए लग रहा है मेरे को तो.
आपको ए लग रहा है? और कोई? Yes, answer is equal to 1. Next, we have a question here. Find the value of R in figure so that there is no current in the 50 ohm resistor. Do this question now.
20 ओम आ जाएगा मैम.
Okay, step by step करना होता है बेटे. So, no current in the 50 ohm resistor. No current is flowing through this resistor, right? So what does
तो
this
अगर
indicate?
ये होगा तो 10 by R is equals to 20 by 40.
No current is flowing through this means IG वाला current है ना ये galvanometer वाला current, right?
हाँ, IG वाला करंट.
Bridge is balanced. Bridge is balanced. So, okay, your answer is correct, Ram. So ratios are equal because no current is flowing through this circuit. So bridge is balanced. And no current is flowing through this circuit. So bridge is balanced. We'll simply take the ratio and equate. So 10 by 20 is equal to R by 40. So from here, we can get the value of R as 10 by 20 into 40. Okay. 21s are 20, 22s are 40. It's 20 ohm. Write the answer. Done.
Done मैम.
Next question. We have 4 arms of a Wheatstone bridge. They have the following resistances. See, A, B. Let's label this first. This is A. This is B. This is C. This is D. And this is our E. Okay. So this is 5 ohm resistance. So 4 arms of a Wheatstone bridge have the following resistances. AB equals 100 ohm. BC is equal to 10 ohm. CD is 5 ohm. AD is 60 ohm. The galvanometer of 15 ohm resistance is connected across BD. Calculate the current through the galvanometer at potential difference of 10 volt when a potential difference of 10 volt is maintained across AC. So let I be the current flowing in the circuit. This is current I. It goes to A. At the junction, it current gets divided into two. I1 flows through this resistor. I2 flows through this resistor. Again, we have this junction B. Again, current divide हो जाएगा हमारा. Let Ig be the current flowing through the galvanometer. So through this resistor, the amount of current is I1 minus Ig. Okay. अब यहाँ पे क्या था I2 current is flowing है ना. This I2 current and this Ig
I2 plus I.
currents will meet at point D and the current becomes I2 plus Ig here. Now through this resistor, current I2 plus Ig is flowing. Again at the junction at this point C, currents will meet. Ig cancel हो जाएगा and we're left with this I1 plus I2 only, and I1 plus I2 is nothing but I. Yes. So I is I1 plus I2. We have to calculate current through the galvanometer. We have to find the value of Ig here. Current through the galvanometer. How will you find? So let's consider the loop BADB first. BADB. This loop we are taking. This loop. Okay. We are considering this loop. ABDB, ABDA, you can write ABDA also. So how will you write? It's 100 I1. And then we have this 15 ohm resistor and Ig current is flowing through it. So we'll write 15 Ig. We are simply multiplying current with the resistance. Okay, current with the resistance. Current is I1, resistance is 100. Current is Ig, resistance is 15. But when we go to this third resistor, you can see the direction of the arrow in which we are going, and the direction which current is flowing is
This
opposite.
is the opposite direction, so it would come as 60 I2.
Minus.
Minus 60 I2.
I2.
Negative.
And if this is equal to 0, because we have no battery, nothing, no cell here, right? So now simplify this. It's 20I1, all are multiple of, we can see 5. So 3Ig minus 12I2 is equal to 0. Let this equation be 1. Okay. Now consider another loop.
दूसरा लूप ले लेंगे ना BCDB.
तो दूसरा लूप ले लेंगे. अब हम ये लूप ले रहे हैं. ठीक है. It's BCDB. BCDB. Apply the equation. Apply the voltage loop rule here. Okay, voltage law loop rule here. Kirchhoff का जो था. So you will get this 10I1 minus Ig. Now minus 5. Why minus 5? Because see, we are moving in this direction, huh? But current is in the opposite direction. So minus 5. In the bracket, we will write I2 plus Ig. Now go to this. Again negative. It's minus 15 Ig is equal to 0. Now simplify this. You will get the relation 2I1 minus 6 Ig minus I2 is equal to 0. Let this equation be 2. Now consider third loop. See how many variables do we have here? We have I1, we have I2, we have Ig, we have 3 variables. So at least 3 equations are required. Okay. So A, D, C, E, A. Consider this loop. A, D, C, E, A. So it's 60I2, ADC. ऐसे जाएंगे ना हम? 60I2. Then we have this positive plus 5I2 plus Ig is equal to 10. Now solve this. Simplify this. You will get 65I2 plus 5Ig. So multiple of 5. So 13I2 plus Ig is equal to 2. Let this be 3. Okay. Please write all the equations. See, now look at these two. First and second. We are going to multiply second by 10. Yes. Multiply second equation by 10 and compare this equation with 1. I think we need to add or subtract this. Subtract these two. We are comparing coefficients. We are solving these two equations by comparing coefficients. Add or subtract? Second equation multiply by 10 gives 20I1 minus 60Ig minus 10I2 is equal to 0. This is your, let's say, fourth equation. Now solve these two equations, first and fourth. I'm going to clear the screen. I'm going to erase this, okay?
Yes, ma'am.
You all have written na, the first equation?
Yes, ma'am.
Yes.
Okay, now first and fourth, we'll add these two. So first equation is, this is the second equation, and first equation is 20I1 plus 3Ig minus 12I2 is equal to 0. This is your first equation, okay? Now add these two. Subtract these two. What will you get on subtracting? Or we can write 63Ig minus 2I2 is equal to 0. So we can write I2 in terms of Ig. So I2 is equal to 63 by 2 into Ig. Or we can write I2 as 31.5 Ig. Now put the value of I2 in 3. In the third equation, you'll get the value of Ig. I'm going to clear this now. It's 13. For I2, we will write equation 3 becomes, है ना? We are putting the value of I2 in third equation. So 13, I2 is, let's write 63 by 2 only, 63 by 2 Ig plus Ig is equal to 2. Now you can solve for Ig. What value of Ig you are getting? बताओ क्या है? It's 2 upon 410.5 ampere. And we can write this answer, this in milliampere as 4.87 milliampere is the answer. So this is our answer. Done? बेटा अगर हो गया तो बता दो मुझे.
हाँ जी मैम.
You all have written?
Yes.
बेटा यस, मयंक, मनसा, गौरिका, आर्षय, लवन्या सबने लिख लिया बेटा? मैं आगे मूव करूं?
Yes, ma'am.
Yes ma'am.
Next topic, meter bridge. See, it is a special case of Wheatstone Bridge. In this, we, instead of taking, resistor that we draw, we use wires. Okay. लाइट वहां से ऑन कर दो, प्रोजेक्टर बंद कीजिए. प्रोजेक्टर चलने तो लाइट ऑन करो. ठीक है. So instead of taking resistor boxes, we take wires. And आपको पता है ना, वायर की भी रेजिस्टेंस होती है, राइट? है ना? रेजिस्टेंस ऑफ अ वायर इज डायरेक्टली प्रोपोर्शनल टू लेंथ ऑफ द वायर, एरिया ऑफ क्रॉस सेक्शन ऑफ द वायर. So this device is a practical application of Wheatstone Bridge, and it is used for measuring an unknown resistance and verify the laws of resistances. So we have metal strips are used for low resistance. Wire AC is made of nichrome, manganese or constantan, is due to high specific resistance and high resistance value. This is a meter scale, battery. A rheostat is connected to reduce current in the network. And we have this resistance X, this resistance R, and this galvanometer. And we have a jockey here. This jockey is attached with a galvanometer, and we इसमें क्या करते हैं हम कि jockey is free to move on wire AC. We can slide this jockey on this wire AC. So AC is a wire जिसमें हम jockey को slide करेंगे. एक X रेजिस्टेंस हो गई और एक R रेजिस्टेंस हो गई. ठीक है. अब जब की को आप क्लोज करोगे, then current is allowed to flow through the current circuit. Now see, this is the position, this D point ना, this D point is the position where galvanometer shows no deflection. तो यहाँ पे हम क्या कर रहे हैं? We are considering this part of the wire, this length of the wire as one resistance, and this part of the second half of the wire as second resistance, and these two are third and fourth resistance. In this way, we have four resistances, you can see, and we have this galvanometer in the middle, and this galvanometer is attached with a jockey. Jockey को we slide the jockey on this wire, और वहां पे इसको बहुत ही केयरफुली हमें इसको मतलब इस पे स्लाइड करना होता है, बिकॉज आपको पता नहीं चलता कब इसमें डिफ्लेक्शन, आपको जो है नल डिफ्लेक्शन देखना है. Null deflection means there is no current flowing through the galvanometer. If there is a deflection in the galvanometer, it shows that there is some current flowing in the galvanometer, right? So we have to find the point where galvanometer shows no deflection. That's the null point. Okay. Then we may take the length Lx, and the second half is 100 minus Lx, because first half आपका अगर Lx है तो second half would be 100 minus Lx. We measure the length. And अब यहाँ पे क्या है, because हमारे पास we have length of the wire, we do not have the resistance. Okay, so we take resistance per unit length, sigma. resistance per unit length. Okay, so X by R is equal to resistance of wire AD. आपको समझ आ रहा है? यहाँ पे दो रेजिस्टेंसेस वैसे हो गई और दो रेजिस्टेंसेस के प्लेस पे वी हैव एक वायर है विच इज 100 इट्स मीटर स्केल. ठीक है, तो मीटर स्केल है, ये इतनी लंबी वायर है. तो अब उसमें इस एक पार्ट हो गया और दूसरा पार्ट, ये दोनों पार्ट्स जो है ये रेजिस्टेंस की तरह एक्ट करेंगे. तो रेजिस्टेंस ऑफ वायर एडी डिवाइडेड बाय रेजिस्टेंस ऑफ वायर डीसी. ठीक है, एनी डाउट इन दिस?
नो मैम.
क्लियर है? पक्का? मूव करें आगे. Okay, now because see resistance of wire AD, how will we find resistance of a wire? तो अब हम क्या करेंगे? We'll use the term sigma here. Sigma is resistance per unit length. Okay, resistance per unit length. So if we have Lx length of the wire, then how will you find the resistance of that length? क्या करेंगे? We'll multiply this sigma with the length, we'll get the resistance. And we are assuming कि यहां पर जो रेजिस्टेंस है ये आपके यूनिफॉर्मली है, मतलब ऐसा नहीं है कि रेजिस्टेंस पर यूनिट लेंथ जो है वो चेंज हो रहा है, इट इज कांस्टेंट. ठीक है, पूरी वायर में सिग्मा की वैल्यू इज अ कांस्टेंट. ओके, तो R is equal to sigma L. So in place of resistance of wire AD, because it is resistance, so we'll write sigma Lx, and for wire DC we'll write sigma into 100 minus Lx because that's the length. Okay, अब आपका क्या होगा? सिग्मा सिग्मा हमारा कैंसिल हो जाएगा and we are left with this only. So X by R is equal to Lx upon 100 minus Lx. So this is the relation. So in this way we can find the value of X. So X we are assuming as the unknown resistance or R is the known resistance. तो ठीक है, तो एक रेजिस्टेंस बॉक्स की रेजिस्टेंस आपको पता है, दूसरे रेजिस्टेंस की अननोन रेजिस्टेंस को यू हैव टू फाइंड आउट. आपने क्या किया? जॉकी को स्लाइड किया है ना, और आपने वो लोकेशन फाइंड की where galvanometer shows no deflection. If the galvanometer is showing no deflection means no current is flowing through that circuit. A bridge is balanced. A bridge is balanced. तो वहां पे जो व्हीटस्टोन ब्रिज वाला कॉन्सेप्ट है, where we take the ratios and equate them, वो सेम हमने अप्लाई किया because we had wires. So we had taken resistance per unit length और उसको हमने उसकी लेंथ से मल्टीप्लाई करके we have got the resistance and this is the relation. ठीक है, now please write this. That's not conductivity. वो सिग्मा था कंडक्टिविटी. This sigma is not conductivity. This sigma is resistance per unit length. It is measured in ohm per meter. ठीक है, क्लियर है? तो रेजिस्टेंस पर यूनिट लेंथ, और हम ये अज्यूम करें जैसे हम मास डेंसिटी कांस्टेंट ले लेते हैं ना कि यूनिफॉर्म है, तो ऐसे हम ये मान के चल रहे हैं कि इसका रेजिस्टेंस यूनिट लेंथ का रेजिस्टेंस सेम है एवरीवेयर. अगर आप वायर का यूनिट लेंथ लेते हो देन यू आर गेटिंग द सेम वैल्यू ऑफ रेजिस्टेंस. For 1 centimeter we have the same value of resistance. For 1 meter we have the same value of resistance every time. छोटे छोटे 1 मीटर में अगर उसको आप ब्रेक करो तो यू गेटिंग द सेम वैल्यू ऑफ रेजिस्टेंस. तो सिग्मा इज अ कांस्टेंट. तो चाहे इधर से लेंथ में मल्टीप्लाई करो चाहे उधर से लेंथ में मल्टीप्लाई करो, इफेक्ट नहीं पड़ता उसका. I hope you all have written.
Yes, ma'am. Yes, ma'am.
Okay.
Yes,
So
ma'am.
our next topic in meter bridge is end error in meter bridge. अब end error क्या होता है? What do you think? End error क्या हो सकता है और ये क्या चीज है? क्या लगता है आपको? Any idea? कोई any guesses? देखो वायर है,
एंड एरर क्या होता है ना मैम, मीटर ब्रिज में ये चीज होती है कि अगर कोई रेजिस्टेंस की वैल्यू वो पर्टिकुलर ना होकर के उसके अप्रॉक्स या उससे बड़ी या उससे कम आ जाए, जैसे कि यही होता है ना मैम.
देखो एंड एरर, उस वर्ड को अंडरस्टैंड करो. एरर एंड की वजह से, एंड एरर इन मीटर ब्रिज. Sorry, I can't hear you clearly. Who's there? देखो एंड एरर मतलब जो वायर है वो कनेक्टेड होती है एंड्स में, राइट? तो हो सकता है कि हमारा जॉकी कहां तक जा रहा है और कैसे मेजरमेंट ले रहे हो आप. सी, एंड एरर इन मीटर ब्रिज इट अराइजेस ड्यू टू द फॉलोइंग रीजंस. Number 1, the zero mark of the scale provided along the bridge may not start from the position where the bridge wire leaves the copper strip, and 100 centimeter mark of the scale may not be at the same position where the bridge wire just touches the other copper strip. एक तो ये reason है इसका. Second, the resistance of the connecting wires and copper strips of metal bridge have not been taken into account. Okay. And how do we reduce end error? How can we remove end error? This can be removed by repeating the experiment. Or we can do one more thing. See, ऊपर कौन सी resistance थी हमारे पास? We had X and R. We can interchange their positions and take the average value. Okay. So end error in meter bridge can be eliminated by changing X with R and R with X. Okay, interchanging their positions and repeating the experiment. So we get the average value, and that average value is free from end error. Okay. So now we have a question. In a meter bridge experiment, when the resistance in the gaps are interchanged, the balance point did not shift at all. The ratio of resistance must be very large, very small, equal to unity, 0. Give me the answer. अगर जो रेजिस्टेंस जो है गैप्स में अगर जो ऊपर वाले उसको इंटरचेंज कर देते हैं और बैलेंस पॉइंट जो है वो शिफ्ट नहीं होता है तो रेजिस्टेंस का रेशियो क्या है? वेरी इजी क्वेश्चन. सोचो सोचो.
C.
Who is saying C? Who is answering C? इतना इजी क्वेश्चन, why are you taking so much time? Sneha, can you answer this? Arshya, Mayank, Lavanya, Gaurika, Lakshay, Vivesh, Mansa. Any idea? If we interchange the resistance, the balance point did not shift at all. इसका क्या मतलब है? ऊपर के जो दो रेजिस्टेंस है, अगर आपने इधर वाला इधर लगा दिया, इधर वाला इधर लगा दिया, लेकिन जो बैलेंस पॉइंट था जिस स्केल में वो शिफ्ट नहीं हुआ, वो चेंज नहीं हुआ, इसका क्या मतलब? इक्वल टू यूनिटी. अगर कोई फर्क नहीं पड़ रहा है इसका मतलब क्या है कि दोनों की वैल्यू सेम. नेक्स्ट क्वेश्चन. Yes, do this question now. In a meter bridge, the null point is found at a distance of 33.7 centimeter from A, one side. If now a resistance of 12 ohm is connected in parallel with S, the null point occurs at 51.9 centimeter. Find the value of R and S. Please do this question now. Hanji. In a meter bridge, the null point is found at a distance of 33.7 centimeter from A. If it is 33.7 centimeter from A, then what is the measurement from B? It's 100 minus 33.7 centimeter. Okay. Now use the relation x upon y is equal to L1 upon 100 minus L1. Okay. So here we have R and S. So we'll write R upon S is equal to 33.7 divided by 100 minus 33.7 is 66.3. R key value we don't know. It's given. Yes. If now no. R key value given. If now a resistance of 12 ohm is connected in parallel with S, we have added one more resistance. If we connect 12 ohm resistance parallel to S, then null point occurs at 51.9 centimeter. Null point occurs at this point. Let's say at this point. Okay, it occurs at 51.9 centimeter. Okay, now what is the S equivalent? Find S equivalent first. These are in parallel, so it's 12S divided by S plus 12. Okay, R1 R2 upon R1 plus R2. This is how we do now for parallel combination. So R upon, this time we will write R upon S equivalent is equal to 51.9 divided by 100 minus 51.9. 100 minus 51.9 is 48.1. So it's 51.9 51.9 divided by 48.1. Okay. Now S equivalent is this, है ना? अब क्या करेंगे next? करूँ? So let's divide these two. Let this be 1 and this be 2. So 1 divided by 2 gives 1 divided by 2 gives. It's R by S divided by R. We have this S equivalent, so we can write this as 12S here and S plus 12 here. And this is equal to, first we will write this part 33.7 upon 66.3. And here we have 51.9 divided by 48.1. What will you get? R cancel, S cancel. So here we have 12 upon S plus, or we can write S upon, no, 12 upon S plus 12, है ना? 12 upon S plus 12 is equal to 33.7 upon 66.3. इसको ऊपर ले जाओगे, रेसिप्रोकल ले लोगे, 48.1 divided by 51.9. Now you can solve this for S. What value of S we are getting? See, we have to find the value of R and S. R and S both. So first find the value of S and then we'll find the value of R by putting this value of S here in equation 1. S की value क्या आ रही है? Give me the answer. Have you done? Solve this for S. करना पड़ेगा. Yes, what is the value of S you're getting? Ram, have you got the answer? Hanji?
मैम ये 33.7 और 66.3 कट जाएगा क्योंकि 66
Nearly double है. हाँ काट सकते हो बेटा, because you will get 14 और फिर यहाँ पे ठीक है, nearly double है but exactly double नहीं है, but कट कर सकते हो.
0.52.
No. It's 13.5 ohm. 13.5 ohm. Now you got the value of S, you can easily find the value of R by putting this value of S here. R is equal to? R is equal to 33.7 divided by 66.3 multiplied by 13.5.
6.75 तो नहीं आ रहा क्या?
For R?
हाँ मैम, क्योंकि हमने अगर इसको ये मान के चलते हैं कि अगर 33.7 और 66.3 कट जाएगा तो 1/2 नीचे आ जाएगा, फिर हम जैसे सॉल्व करना चाहे कर सकते हैं.
Yes, 6.86 है बेटा, 6.86 ohm. Answer the following questions. What is the principle of working of meter bridge? Who knows the answer?
Wheatstone Bridge.
Yes. Wheatstone principle. Okay, next question. Why is a meter bridge also called a slide wire bridge?
Because of the jockey which can slide between on the scale, and we can accordingly read of
Yes.
100.
Yes. Because the jockey is to be slided over the bridge wire, and that's why it's called slide wire bridge. Next question. What do you mean by sensitiveness of a Wheatstone bridge?
सेंसिटिवनेस मतलब कि गैल्वेनोमीटर से जो फ्लो नहीं कर सकता.
कोई भी चीज सेंसिटिव कब होती है कि जब वो बहुत ज्यादा रिएक्ट करे छोटी सी चीज में, छोटे से चेंज में वो रिएक्शन बहुत ज्यादा दे, तो वो सेंसिटिव होती है, राइट? अगर यूजली अगर वर्ड आप सेंसिटिव यूज कर रहे हो, है ना, अगर थोड़ी सी बात में इतना रिएक्शन दो तो वो सेंसिटिव होती है। तो व्हीटस्टोन ब्रिज सेंसिटिव कब होगा? दिस इज द क्वेश्चन। सेंसिटिवनेस का क्या मतलब है व्हीटस्टोन ब्रिज? क्योंकि थोड़ा सा चेंज से उसमें वो जो चेंज है उसका जो इफेक्ट है वो बहुत ज्यादा दिख रहा है, राइट? So if it shows large deflection in the galvanometer whenever a small change in resistance is taking place in resistance arm, अगर हम resistance arm में थोड़ा सा भी चेंज कर रहे हैं और galvanometer में बहुत ज्यादा डिफ्लेक्शन आ रहा है, ठीक है,
मतलब इसका ये है कि अगर R1 जैसा हमने व्हीटस्टोन ब्रिज में देखा था, है ना, तो उसको हमने उसकी रेजिस्टेंस चेंज कर दी, तो क्या गैल्वेनोमीटर पे भी फिर लार्ज डिफरेंस हो जाए?
बेटा वो तो होगा, बिकॉज अगर आप रेजिस्टेंस को चेंज करोगे तो उसमें से अमाउंट ऑफ करंट जो निकल रहा है वो चेंज होगा, अकॉर्डिंगली फिर आपका गैल्वेनोमीटर में भी करंट जाएगा तो वो डिफ्लेक्शन शो करेगा। ब्रिज बैलेंस कंडीशन है ना उसकी, ब्रिज बैलेंस होना चाहिए, और ब्रिज अगर बैलेंस नहीं होगा तो गैल्वेनोमीटर विल शो डिफ्लेक्शन।
ठीक है मैम.
है ना, अगर हमारा ब्रिज बैलेंस नहीं है, बिकॉज अगर हम एक रेजिस्टेंस की वैल्यू को चेंज कर रहे हैं बाकी तीन को फिक्स कर रहे हैं तो रेशियो तो नहीं आएगा ना इक्वल, हम रेशियो के साथ
जी.
छेड़छाड़ कर रहे हैं, है ना। अगर रेशियो इक्वल नहीं है, ब्रिज बैलेंस नहीं है, तो गैल्वेनोमीटर में डिफ्लेक्शन आएगा। नेक्स्ट, why is meter bridge method not suitable for measuring high resistances? अभी आपने you have measured unknown resistance using meter bridge. We have taken a wire, one part of the length is one resistance, other part of the length was taken as other resistance, and there were two resistance boxes there. One was known resistance, other was unknown resistance. And the question is why it is not suitable for measuring high resistances?
It is not suitable because on a small change of, because if it reacts on a small change in the resistance, it would react galvanometer in the Wheatstone bridge would react vigorously when the resistance is increased, and therefore give us the wrong reading. मैम सही है गलत?
For measuring high resistance, the resistances of all other arms of the bridge should also be high in order to ensure the sensitivity of bridge. But this will reduce the current through the galvanometer. As a result of it, the galvanometer becomes insensitive. ठीक है, ठीक है। अगर आपको हाई रेजिस्टेंस, अगर आप एक साइड पे हाई रेजिस्टेंस लगा रहे हो तो दूसरी साइड उसके रेशियो को इक्वेट करने के लिए आपको हाई रेजिस्टेंस को ही प्लेस करना पड़ेगा ना। रेशियो रेशियो को तो करना पड़ेगा ना मेंटेन। रेशियो मेंटेन कब होगा? अगर अगर आप एक जगह हाई रेजिस्टेंस लगा रहे हो, दूसरी जगह भी आपकी हाई रेजिस्टेंस होनी चाहिए, तभी रेशियो इक्वल आएगा ना। और उससे
Yes.
क्या होगा? ठीक है, आ गया समझ? टेक द स्क्रीनशॉट ऑफ दिस क्वेश्चंस नाउ। टेकन?
Yes ma'am.
ये आपके क्वेश्चंस हैं आगे, इसका भी स्क्रीनशॉट लो, प्लीज प्लीज शेयर दीस क्वेश्चंस ऑन व्हाट्सएप।
नेक्स्ट चैप्टर है ये तो फोर्थ चैप्टर, जब ये फोर्थ चैप्टर में इंक्लूड होता है फिर ये फोर्थ चैप्टर।
This is chapter 3.
चैप्टर 3 के नोट्स में
You have got the notes. Anything you want to ask?